Yes, hey, welcome back. And I was just going through some sorting algorithms, and I thought, okay, let's do that together. And next few videos might be on some sorting algorithms, and today I'll go over merge sort. And merge sort is a divide and conquer algorithm, and what it basically tells is that when you have an array of elements, just break it until you get the array of size one, and after you have individual arrays of size one, you just compare it with its neighbor and combine it. So that is the so dividing part is the breaking, and the combining part is the conquering part. And let me just explain it with an example. Yes, let's consider this example. So what it tells is that since you have an array of this, first break it into half. So when you break it into half, this will be the two halves. So now what you do? It's not completely broken. So break it again into halves. But what do you see? Lo and behold, it's not completely broken yet. So again, break it into half, and now you see that every element has been broken into individual single elements. So now what you do is next you start combining. So if first you combine 9 and 7 and you see that they're not sorted. So what you do? Combine like sort them and put them in place. So you combine 9 and 7 and swap them around. So 7 comma 9. And then you see 8 and 6. Again, those both are not sorted. So sort them and put them in place. 4 and 5 are sorted. 2 and 3 are sorted. Is your work over? No, not yet. So now you compare the elements with the neighbor. So compare 7 and 9 with 600, and you see that after sorting it becomes 6, 7, 8, 9. Okay, and then you compare 4, 5, and 2, 3, and on sorting it will become 2, 3, 4, 5. And now do the final comparisons of both the arrays. So it will become 2, 3, 4, 5, 6, 7, 8, 9. Yeah, that's how the algorithm works. So you'll first break it. And, you break it until you get single elements. And on getting single elements, just compare and combine. So yeah, it's basically it, and it's very simple. So yeah, class, let's call it Masort. And first, what you do is you'll break the array. Break the array, and after breaking the array, what you do? Merge the array. So now what? Let's make it more presentable. So let's call another class Merge, and it will just return the breaking part of the array. So what will happen after each individual break is that it will automatically be combined and written in the break array itself. So return the self dot. Since I'm inside a class, I have to use self the array which you're getting from the merge source. So you'll have an array over here. And since again I'm inside a class, I have to put self over here to refer to that current object. So now, if you remember what I told, break it until you get an array of size one. And when you have an array of size one, you return it. So if the length of the array at any instance becomes equal to one, that means you are at the base unit. So directly return the array itself to be compared. The comparison will be done in the merge array path. So return the array itself. What is what you do? Calculate the midpoint. And how do you calculate the midpoint? It's not left plus right minus left better. It's not binary search. So you directly take the length of the array and divide it by two. And yeah, you have to do integer division over here. You can't have floating point numbers and set it as mid. So now you have to like take the left half. Left half is actually array from everything else, everything from zero to mid, and right half is actually array from mid to the end of the array. Every element from mid to the end of the array. And now what you have to do? After breaking it, you have to actually merge it. But before merging, you have to again check if the length of the array is one. So first, directly let's call the merge array part. So merge array. But before merging, what you have to do? Again, you have to break it till you have the length of the array to be one. So call the breaking function over here. Yes, call the breaking functions on the left half and the right half, and that's basically it. That's how you break the array. And on before merging the array, you just check if the array is broken until you have length of array of size one. As soon as you have an array of size one, it will directly go to merge array part. So again, self and left and right. Let's declare an answer array over here, and then declare two variables I and j to traverse the actual left and right half. And what you have to do, while I is less than the length of the left part and j is less than the length of the right part. So yeah, what you have to do, do the comparisons now. Like I told you, right, comparing with the neighbor. So compare the left and the right neighbor or left and right element in each array. So if left at position I, by any chance if it becomes less than right at position j, that means the left element was smaller. So append the left at the position I to the answer. And after appending the left position, just increment it by one, or else you'll be stuck in an infinite recursive loop and you don't want that. It will directly eat up your memory and yeah, it's not good. Else what you have to do, right at the position j and then increment j by one. Right at the position j, not at the position right. That makes no sense. And now you have already combined. But the thing is, if the size of the array was like odd, then you would actually be left with one element. So just to make sure that that does not happen, so again you have to do two more loops. So again you have to do the same for right half also. While j is less than length of right, you do j plus it equal to one, and you do right at the position j. And yeah, but Python has provided us with a good way to do this part. So rather than writing this out, what we can do is directly rather than appending, we can extend the array itself. So directly extend the left array of everything from okay, my computer is a bit slow. Everything from the ith index because you have calculated till I to the end of the array, and do the same for the right half also. And believe it or not, your entire merge sort algorithm is done. You can directly return the answer over here. And that's it. So what you do is first you break till you have a length of size one. After you have a length of size one, what you do is you combine while comparing. You do combine while comparing, and then you return that part. That's all it. First time when I heard of merge sort, I thought it would be very difficult to implement it and all, but it is not actually difficult at all. And as you saw, it was pretty simple. So let's create like an object of merge sort, and let's have an array of over here. Uh, Let it have what do you tell? Yeah, this looks like a good array to me. And then let's have some smaller element. Okay. Why that's showing an error over here? It should not show. Yes, it's because I forgot a comma over here. Okay. Now let's call the merge sort function defined inside the merge sort class. Merge sort dot merge sort. Merge sort the ARR, and it will actually return us the sorted array. So let's call it sorted ARR. Now just print the ARR and the sorted ARR. And then just let's run it once to check if it is working properly or I might have made some mistake. And as you see, the array which we get is sorted 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, some bigger number. And yeah, with very small modification, you can actually sort it in descending order. So just change the sign over here. When you change the sign over here, what will happen is that it will give you in descending order. And it's so simple. For ascending, you just make it greater than when left is smaller than right, and for descending, you make it when left is greater than right. Just for just one for let me show. When you do left is smaller than right, you will get in ascending order. When you do left is greater than right, you get in descending order. And yeah, that was it. Merge sort was pretty simple. Don't get scared by the name merge sort. It is actually very easy to implement. And yeah, that's all it. And the actual difficulty comes when they tell you have should not use extra space to do this. And there is another completely different way to do that, and that is like extremely hard. And I'll just go through it once, and if I can, then I'll upload a video on how to do much sort without using extra space also. And yeah, that's about it. Thank you for watching. Bye.